Hello, everybody. This is Salim Khan with Texas Energy Engineering Services, and today we'll be going over the energy accounting and benchmarking presentation. So just bear with me. I'm traveling today, so I'll be doing my best to keep all the technicalities in place so that we have a smooth presentation. So just wanted to give you all a quick recap of where we are. This is part of a SECO Facilities Infrastructure and Energy Management webinars. We, on the 20th of this month, we did indoor-outdoor lighting retrofit options overview. So that's the one that you see in the light gray over there. Today, we are going to be going over energy accounting and benchmarking. Tomorrow, we'll be going over Energy Star Portfolio Manager. And then in August 1st and 2nd, August 1st will be preliminary energy assessment overview, and on the 2nd will be energy efficiency consideration for water and wastewater systems. So specifically for water wastewater systems will be on August the 2nd. I'd like to welcome everybody, and I'd like to thank you all for taking the time and for listening to this webinar. I'll be going over some of the main topics or some of the main items that need to be covered for energy accounting, and the goal over here is to provide you a general overview. This program or this webinar is part of the SECO Schools and Local Government Technical Assistance Program. So a lot of the things that I'll be covering over here, if you had asked for this technical assistance or technical assistance or technical service, you get one-on-one on some of these items that I'll be going over. So anyways, again, I'd like to thank you all, and we'll proceed to the first slide over there. Why energy accounting? Primarily to compare energy consumption and cost, and you want to do that over time and among other facilities. So you may have more than one facilities. You want to compare them and see how they're individually doing, and you want to do it over time so you can track, see how the facilities are performing over time. You want to do energy accounting to identify energy spikes and billing errors. So that's an advantage of doing energy accounting. Prioritize energy capital investments. So if you are doing energy accounting or benchmarking of your facilities, you will kind of know which facility you need to focus on, and maybe that's where your capital investment needs to be. Evaluate progress and communicate results. So one other important function of energy accounting is that you can evaluate if you've implemented some programs, you can evaluate how they're doing, and most importantly, you can communicate results, basically, right? So if so that's an important function. You can also, some people have done this, specifically in school districts. They've created incentive for energy management, so they're doing benchmarking, and specific schools that might be doing better are given some incentives basically to encourage them to do more. So that's another advantage of it. Another really great tool as a result of energy accounting is that you can improve your energy budget forecasting. So if you are doing your regular data logging on the utility bills, you can improve your forecast, and later on I'll explain to you how that is done. And then importantly, that you can, if you're doing this on regular basis, you will be keeping track of changes, the square footage changes, the occupancy changes, and so on and so forth. So basically, these are some of the primary reasons that you'll be doing energy accounting. What is the first step in getting started? Basically, how do you get started? So you set up a team and assign roles. So just remember that that energy, recording and keeping track of all the data, it needs resources. So you need to set up team and assign roles. Then you need to allocate time and resources, which can be manpower resources or other resources for that matter. Then you establish contacts. This is very important, that you know who your utility account representative is, and then also in some cases, or in most cases, a lot of this data is already kept by accounting and finance department, although it takes them a little longer, and you may need this information sooner than the accounting or finance could transmit to you. So having to know your account representative is very important, because you can send him a request, and within minutes or the next day, you might get all your utility profile that you could upload, and so on and so forth. So that's important, knowing your utility account representative. Now, it's important that you gather all accounts and facilities information. For example, you may have electric in certain facilities, natural gas, propane, water, or anything else. So different people have different objectives. Some just want to capture electric usage. Some wants to do everything that's fuel related to their facilities, which would be a more comprehensive way of doing it. Work to optimize procedure. Now, what is meant over here is that when you're in the planning stage over here, you need to think through the process, think about all the stakeholders that will be involved in it, and you need to optimize your procedures so that you can do your work more efficiently. One important thing that you need to do is that you need to decide on who's going to be doing the data recording and what is the frequency. So if you want to do it monthly, quarterly, or semi-annually, it all depends on what kind of resources have you allocated, including time, basically. So, and very important is try to reduce double entry and help streamline the procedure. So in other words, if your utility account representative can send you the information electronically, ideally you will take that information and upload it to your own spreadsheet, or to your own commercial software, or any other software that you might be using for tracking it. So minimizing double entry is important. So the first poll questions, and I just need to give you a heads up that as we go through this presentation, we may have 1 or 2 poll questions, and primarily they will be broadcast. So the first question over here is, do you or does your organization conduct meter mapping? So I believe something should pop up on your screen, and then you can just answer, and as soon as you all close it, I'll tell you the result of it. So it looks like 20. Oh, it's still in progress. I'm sorry. And we'll be closing the poll shortly. So all right. So it looks like 50% said yes, we do that. 30% said no, and 14% is saying what is meter mapping. Okay. So we'll be going over some of this stuff later on. So it looks like it's almost 50% of you are doing something like that, and non-book 36% may not be conducting meter mapping. All right. So it is important to identify utility meters. Identify all meters' location and determine which facilities they serve. That is important. So in other words, you need to know where all these meters are, basically, and which buildings are they serving, or locations they are serving. Ideally, you will create a utility meter list and a meter map. Now, some of this information you may be able to work through the account representative, but in most cases, our experience is that you have to go there and physically locate, because the billing address that you may have on the meter may not be exactly the location where you'll find these meters, basically. Determine if multiple meters serve several buildings. So there are occasions in which you may have multiple meters, or one meter serving multiple buildings. So you just need to know that detail. And you need to group facilities in a logical manner according to the utility meter served. So you do a grouping of your facilities, you try to figure out which meters are serving which facilities, and that way you have a good information that will help you in your benchmarking and tracking. Grouping facilities by utility meter served would help in benchmarking and the facilities. So I'll explain that to you, how that helps and where does that come in handy. So very important is getting to know your utility meters and the locations of your utility meters. So on the screen, you're looking at an example of utility meter mapping. This was done as part of the SECO Schools and Local Government Technical Assistance Program, in which one of the, I think this was the school district that requested, as we were doing the energy survey of their facilities, they requested if we can help them with meter mapping and identifying location of the meters. So you see that there's a bird's eye view and then the meter locations. Now the information may not be clear, but you get an idea that that's what we're talking about, meter mapping. So ideally, I like to see an energy manager have something like this so that they know where their meters are. And by doing this, we have run into multiple occasions where people have found abandoned meter that they've been paying, you know, just the service cost, but they were not used basically. So doing this actually has got some other benefits besides just the benchmarking part of it. This is another example, and this is a local government facility. We can see it's a wastewater treatment plant, and they have a number of utility meters over there. And in this case, assistance was provided to group the meter locations and then identify the boundaries they were serving. So when I talk about meter mapping, I'm talking about, or I'm requiring that, or I'm requesting that you have something like this. You can have a Google overview, and then you can place your meters over there, which is very, very helpful. Getting the facility data. So the second step in your energy accounting and benchmarking is getting the facility related stuff. The most important thing is the square footages, and you will see later on when I show you the benchmark, the square footage plays an important role. So where can I get the square footage data? So a lot of the organizations that have got built-in larger facilities or facilities construction departments, they will have a lot of this information with them. In other places, in smaller facilities or smaller public entities, we found that usually you will find this information when you go to accounting, where they keep the insurance information, and the insurance information usually will have square footage of different facilities along with some descriptors basically. So I think going to the finance and accounting department to get this information, or go to the facilities department where they might be keeping running a tab of all the square footage and what kind of buildings you all have basically. So very important thing is that you got to keep track of building addition and renovation. So if you add another 5,000, 6,000 square feet, it'll be good to note that because it has an impact on your benchmarking. Identify operations and schedule changes. Now, this is not really required for benchmarking basically, but this is good information to have. This is you need to know the temperature settings, heating or cooling, what kind of temperature settings are people keeping, and what is the occupancy type, and what are the operating hours. Now, this information is useful and is required in Energy Star Portfolio Manager, which we'll be going over. We will be going over tomorrow, but today we'll just give you a quick overview of that. So this is something that is good to have if you're going to be doing something like Energy Star Portfolio Manager. Now again, the list that I'm going to go over is not required, but again, good to have. Basically, you need to, if you can get a general description of HVAC and other energy using equipment, the number of occupants, is your HVAC electric or natural gas, the number of computers in the facility, what kind of appliances do you have in the kitchens, electric or natural gas. Again, some of this information may not be strictly useful for direct tracking, but if you're doing Energy Star Portfolio Manager or something like that, this information is good to have. And the side benefit of this is that you can go look at your facilities. You may have a chill water, air cooled, water cooled, DX system, and you can go look at which facility is doing better than other depending on what type of system they have. So it has a side benefit if you do that. Again, over a period of time, you will have upgrades to your equipment, especially the HVAC equipment. It will be good to note that, because if there are fluctuations in your utility bills, maybe that's one of the reasons for that. that. So again, not necessarily that you need to have it for a simple benchmarking, but in order to have a better understanding of what is happening in the facilities, it will be good to gather all this information or get to know this information better. Again, establishing baseline, that is very important, and usually at least one calendar year, 12 consecutive months will be considered as a baseline. So important factor is that you decide which one is your baseline, and then you may be doing that for a variety of reasons. And then if you're implementing projects, then you can compare them to your baseline to see how you're doing. Review monthly invoices, scan invoices, or your tracking spreadsheets, software, contact the utility provider. Again, getting the information from utility provider is very, very useful and sometimes extremely fast. Electric consumption, important. Just want to point out that a lot of people record consumption, which is the kWh. However, the reason I have this peak demand or kW in a different color is that I will later on show you why it is also beneficial to record demand, not just consumption. Although, if you're using the Energy Star Portfolio Manager or some of the other programs, the demand is not recorded in there, but it is good if you can do that on your own, and I'll explain to you in a little while why it is beneficial. Again, you like to have all the natural gas and the water consumption and cost data. Again, you can go to the service providers and get some of that information. And once you set it up, then it is easy to follow through on recording these data. Now, if you are a large facility, let's say you are a university or a large campus, then what normally happens, or I've seen some of the school districts also where they have a central plant and they're serving 2 campuses or 2 facilities or a number of facilities over there with different usage. So in that case, it is better to do individual BTU meters for chilled or hot water on each building. So that's where you know how much of a consumption each building has as regards to chilled and hot water. But you will see that in larger more complex buildings or buildings where they've got large chill water central plants serving multiple buildings, basically. So the most important thing over there, energy performance indices. Okay, so the energy use index, which is the EUI, is the total annual electric and natural gas usage. So in other words, what is your annual electric and natural gas usage? It is converted to BTUs, and I'll explain to you later on why it's converted to BTUs. So you get that information, you divide by square footage, and that's your annual EUI, which is energy use index. Now, you will see in a lot of programs that people use K, have a K in front of the BTU per square foot per year. And why K? So that question has been asked a number of times, and the simple answer is that if you look down below, we have a 68,000 BTU. Let's say a facility that is using 68,000 BTUs per square foot per year. It's been found useful if you're charting or graphing these things, and I'll show you later on. All you do is divide by 1,000. And that means that this I could put this building on a scale of 1 to 100, which is easy for people to relate to. So that's the primary reason why you see the K in front of the EUI use, basically. The other index that is the most important, most common, is the energy cost index, which is the total annual electric and natural gas cost, or if you have other fuels, and that divided by the square footage will be the annual EU energy cost index, or dollar per square foot per year, basically. So again, EUI and ECI, they are the most common basically indices that are used in the energy industry. So there might be folks from water and wastewater. I'm not going to go too much into that, but there are similar indices for water and wastewater, basically. For the energy use index for water, wastewater, annual energy use divided by average effluent flow, KBTUs, GPD is gallons per day. A lot of this information, gallons per day, MGD per day, and so on and so forth. Most of the water, wastewater utilities keep track of that as a part of their permitting requirement for, and so on and so forth. So that's the energy use index. The energy cost index is also similar to the building side of it, which says annual energy cost divided by average effluent flow. In this case, is MGD per MGD is dollars per MGD per year, millions of gallons per day, basically. So energy use index and energy cost index. Normalization. A very important thing is to keep in mind is the water wastewater facilities are influenced by the permitting requirement and the process they're using and so on and so forth. So if you are really comparing one water wastewater plant to another one, you need to have those other factors built in for comparison, basically. So now it's time for a second poll question. Do you or does your organization actively track water usage? All right, thank you. All right, looks like people are still voting, and all right, so do you or does your organization actively track water usage? Around about 81, very good. 81% said yes, 14% said no, and 5% said I don't know. So it looks like quite a few people have started doing water tracking. Water consumption and performance. Develop water baseline. Performance indices primarily for water will be total annual water consumption per square foot. So you could have an index that you can compare from one year to next year or from month to month if you like. And total annual water consumption per occupant. I've seen people doing that also, in which they want to look at the the number of occupants and how many gallons they're using per day and so on and so forth. So different ways you do that. One thing I want to keep in mind is that we found out that a lot of places, the irrigation and the domestic water use meters are sometimes, they're not, they may have a 1 meter and then they have a subdivision over there, so they may not exactly know where the exact water usage is coming from. So if you can nail down specific meters that are serving your domestic water and separate them from the irrigation part of it, that will be something that usually takes a little bit of investigating and so on and so forth. Okay, now other indices you can also develop. So one, if you're keeping track of your consumption, you're keeping track of your cost, you can do other things. I've seen a lot of people, a lot of school districts and some other facilities basically doing kWh per square foot. So that's then the electric consumption per square foot per year. They've also done kW. You can also do consumption per occupant, or consumption per number of students, consumption per number of staff members, or whatever you feel like is an index that is important to you, and how much dollar per occupant are you spending basically, and the BTU per occupant, which is what we went over basically. So you can develop your own indices, but the most common indices are EUI and ECI. Again, the indices are used to compare building energy performance, and one thing that I'm not talking about over here is the weather normalization part of it. So anything that I've gone over up till now is not taking into effect that there might be weather fluctuations, and there are software and programs actually to help you with that. But just having the basic data on consumption and cost without the weather normalization is also extremely, extremely useful. So this, if you've been doing tracking your electric cost and natural gas costs, what will happen is that you will see a chart. You can develop a chart like this in which you have the energy use index, or also sometimes called energy utilization index, which is on the left side of your screen. So this, let's say this is our data for 2015, facility A, B, C, and D. The dark blue is electric, the light blue is natural gas, and on the right side is the cost. So cost data for facility A, B, and C. So you have facility cost performance, dollar per square foot per year, basically. So if, let's say, you have 2015 was your baseline, and then you started implementing projects early in 2015, and then you start tracking the 2016, and you will see on your screen, let's assume you develop this. So now you can see what kind of impact, if you've been doing some energy measures, or if you've been doing some low cost, no cost measures, some simple start stops and simple things, and maybe some capital retrofit projects. This way, if you have the basic data and you've been updating it regularly, you will be able to do comparison like these. Again, this is not weather normalized, but later on I'll explain to you how you could achieve that with the free software, basically. So again, something very useful. And then if you're doing it over the years, you can have all this data in front of you, which will be very useful in forecasting. So the question normally is asked, because BTU is not a very common term. BTU is British thermal unit. So the reason energy consumption is expressed in BTU is to allow for consumption comparison among fuel types that are measured in different units. So I'll just give you an example. So in other words, you could have different measurement units, basically, for natural gas, for electricity, and so forth, propane, whatever you have. There are conversion factors that you convert them to BTUs, and that way you can add, subtract, and so on and so forth for your benchmarking. So that is primarily the reason you do BTUs, to get a more comprehensive look at how you are using energy per square foot at your facilities. So, for example, if you have kWh, then there are conversion factors for that. You multiply it with those conversion factors, and it will convert it to BTUs. So that's an example. The other example that just popped up is the natural gas consumption to BTUs. So there are conversion factors for CCF and MCF of natural gas conversion to BTUs. So depending on how you're tracking, you will use those conversion factors to come up with the BTUs of natural gas. Now, if you have some other kind of fuel, let's say in this case propane to BTUs, so it has a different conversion factor. So just knowing the conversion factor and converting them to BTUs enables you to actually look at a more comprehensive look at the facility with all the fuels that's being used over there. Another poll question: do you or does your organization actively track electric demand, which is KW, electric demand? And we'll start the poll. So around about 67% of the people responded. Close to, I'm really surprised at that, close to 75% said we are tracking demand. 20% said no, and most of them knew what it was, and then 5% said what is electric demand. So that's good. That way I can clear it up. But usually I would expect this answer to be the other way around, in which very few people will be tracking demand. So, but anyways, I'm going to go over the electric demand and what it is and why is it important. So electric demand, not typically tracked but can be beneficial. Okay, I want to make sure that we are talking about KW. Okay, KW, not KWH. A lot of people have confusion between KW and KWH, but I want to make sure I'm talking about demand, KW. Large commercial buildings may represent, large commercial buildings, almost 30 to 50% of the cost could be demand cost, and that's what we found through looking at a lot of these facilities. What is, I think there was a question before I get into this, is what is demand basically? So demand is primarily if you have a larger building, typically you will have demand charges, and the utility has a meter actually that records, and typically in 15 minutes interval, how much of a peak kW did you use, and then it records that and it keeps that, and for that month it will keep the highest kW that you used, and then there is some sort of a charge that will be applied to for using that peak demand in that billing period. Now, why do utility do that? They do that basically so that they have to have power generating capacity, and in order to have that power generating capacity, they need to have ways to actually recover that cost, and that's why you will see a demand charge in your bills basically. So consumption is kWh and demand is kW. Again, I'm not going into too much. There are a lot of different ways to explain that. I'm not getting into the detail of the rate analysis, which is a topic by itself, basically. But just important to know that demand charge could represent 30 to 50% of your electric cost. Additional advantage of tracking demand is the ability to calculate the building load factor, and I'll explain that in a little while, what a load factor is and why is it useful and how do you get it out of the demand charge. So electric demand will be peak power draw, which will be kW, and then your bill demand charges. So now if you're tracking your demand charges, you could generate a chart like this basically that tells you in each month how much of a demand charges or kW did you draw and how much did you pay for it basically. Okay, so that's useful information to have. The advantage of doing this is that you could pretty much decide on it could really help you on an energy savings by just if you start starting your equipment at slightly 15-20 minutes interval rather than all at the same time, which will help you reduce your demand charges because all the equipment didn't come at the same time. And if you turn everything on at the same time, what will happen is that's where the utility is going to record how much energy did you use, and that's what you can be billed for basically. So there are other ratchet clauses and so on and so forth where it could go over a year period of time, the maximum kW use. But again, I'm not getting into the nitty-gritty of the utility rate analysis. But if that's a topic that I think we normally ask the question, if people are interested, we can have a specific seminar, webinar on that too. So anyways, if you're doing demand charges, this is something you will be tracking. This is something you will know. Now, what is a load factor? Load factor analysis. So load factor is the ratio of average kW to peak kW in a billing period, okay? So if you have that information from your billing period, you can do a load factor analysis, and typically a load factor analysis represents a consistency of facility use. So I will explain that to you in a second, basically. So if we are doing that, you see different months over there. This is an example, basically, and on the left side, you see electric load factor analysis. So typically, if you see your load factor, let's say above 30%, that usually implies that you are having after-hour use, okay, basically. So the higher the load factor, the higher the probability that you're using your equipment after hours. Now, there could be legit reasons. You may have a facility that is a 24/7 facility. In that case, you would expect a higher load factor. But if you've got a office facilities, police department usually have higher load factor because they're 24/7. Water, wastewater will have higher, but other facilities may not need to have higher load factor. But if you're doing this load factor analysis, you can look at it and say, oh, probably some things are staying on, or what is the reason for after hour usage, basically. Sometimes there's a legit reason. People have requested after hour usage, but a lot of times you'll find out that maybe you told your EMS and so forth to turn some of things on, but they have gone into override or they're in hand position and so on and so forth. So when we do the initial analysis, we run into a lot of those kind of scenarios, and the load factor is very important information for us to have to kind of cross-check equipment and operations, basically. Budgeting. So the importance of doing energy accounting is that it could be very useful tool for you for budgeting, basically. Now, I said energy manager, but really it doesn't have to be, and you could be a facilities manager, facilities maintenance supervisor, director of facilities, so on, or even the finance department. Having the budgeting is an important function, but it's very important for the energy manager, because sometimes they will come and ask you what should the utility bill be for the next year or next month, and so on and so forth. So energy accounting tools. Now, if you have been doing a recording of your historical consumption and cost, okay, and if you've been doing that pretty regularly, then you can forecast consumption and cost. And I'll just explain to you in just a second how you could do that. Very simple, 2-3 steps involved in it, and you can get a fairly good estimate of your future consumptions and cost. It's very important to keep in mind is that the energy management activities, they all require some staffing, they all require some manpower. Basically, you may need some equipment, and also if you're looking at energy retrofit kind of an options and so on and so forth, if you're doing energy accounting and you're tracking your historical consumption, some of these things will be very useful for you to make certain decisions as you move forward, basically. So, estimating future utility budget. I just wanted to give you all a quick example based on the EUI ECI. Based on the EUI ECI, I just wanted to give you all a quick example of how you can do forecasting. So we just created a hypothetical scenario over here. Assume you have a 100,000 square foot facility, and your total annual energy cost is, let's say, close to 100,000 per year, just to keep it simple per year. There'll be soon 20,000 square foot addition to the facility next year. So you've been told that there'll be an addition to the facility close to 20,000 next year. And what you've been asked is, what will be the estimated electric budget for the building addition, if assuming it's got similar occupancy, usage rates, HVAC system. So in other words, they are either adding to this building or they have a building adjacent to it, basically, and they've given you have the information on your existing facility. So let me show you how you can use the EUI and ECI information that we discussed earlier to kind of do your forecast or budget for the next year. So again, the known values are existing square footage is 100,000 square feet. Annual electric cost last year was 100,000. So facility addition square footage is 20,000 square feet. So first you calculate your annual electric cost index, basically, for your original building. So it will be 100,000 divided by 100,000 square feet, which is $1 per square foot. So $1 per square foot is your energy cost index, basically. So projected addition energy cost for next year, you take your $1 per square foot and how much of a square footage you're going to be adding, in this case 20,000 square feet. So if you multiply, you'll say, oh, my estimate budget, all assuming everything is pretty similar, is going to be an additional 20,000 per year is what I'll need. So very useful information if you have been doing tracking and so on and so forth. Now, just keep in mind, if the 20,000 square foot addition is going to be a data center, then that has a whole different implications, basically. So you got to be able to make those judgments whether, you know, what kind of addition it's going to be. But if it's going to be a similar addition to what you have, you can easily do forecasting with the historical data. The other concept that I wanted to go over was a simple payback. A lot of people are very familiar with it, but still they've been question asked about it, so I just wanted to quickly go over it. Simple payback is primarily an initial cost divided by annual savings. So what is your initial cost to do certain thing, and what are your annual savings as a result of that? A lot of programs such as the Lone Star program and other the preliminary energy assessments, we do simple paybacks because it's easy to understand, easy to follow, and that way you can prioritize your investment. So determines the number of years required to recoup the cost of initial investment. So that's by definition, simple payback will be how many years does it take to recoup your initial cost, basically. The annual saving can be other quantifiable savings. So I'll explain that to you in just a second. Now, we have a similar, I've created another simple example over here for payback calculation. So it costs $100,000 to retrofit existing T8 linear fluorescent lighting to LED lighting at your building. The estimated annual energy savings are calculated to be $1,500 per year. What will be the simple payback for LED lighting retrofit? Okay, so your project cost is $10,000. Your annual savings are $1,500 per year. Simple payback will be cost divided by savings, which will be 6.6 years in this case. So you can easily deduct. Now you may have an HVAC project, boiler, building envelope, or different things. That's how you have your payback over there. Now, other factors you could put into play also. If you have some maintenance savings or you have some rebates, so then you can use that information over there, and then your payback is going to be less. So you know, there are different factors, different things you want to look at it. Typically, when a Lone Star program, an investment grade energy audit is done, mostly it is simple energy savings, and a lot of the other things are discounted. Another concept I want you all to be very familiar with is, which is primarily used a lot to justify some of these projects, is a cumulative simple payback concept. So utilize the savings of multiple projects to improve the overall cumulative payback. So you may have projects with higher paybacks, you combine them with a lower payback project, and the cumulative payback will be combining both of them. So in this case, what you see is the HVAC project, let's say it has the initial investment of $100,000, project saving of $6,500, a simple payback of 5.4 years. A lighting retrofit cost you, let's say, $75,000, saved you $18,750, and a simple payback of 4. So what you do, you put all the costs together, you put all the savings together, and you divide them. So now your cumulative payback in this case is going to be 7 years. So this is an important concept to have, especially if you're doing energy retrofit projects or renovation projects, basically. And ideally, what you want to do is, because a lot of people want to address their HVAC needs, which typically have got longer paybacks. So you need to find if you're, let's say, if this was a Lone Star program, a traditional one, which a payback of 10-year criteria, basically. So your HVAC alone would not be able to be justifiable, but if you have some other low, faster payback projects, you can use that, and as long as your cumulative payback is less than 10 years, basically. So important thing is, I just wanted to make sure that everyone is clear about what is meant by cumulative payback, and wanted to cover that. The other things, very quickly, I will go over. These are things that you typically may hear about in energy accounting and so forth, are the cash flow diagrams. So primarily, very simply put, this is not, there could be a lot of different variations to it. But if you see something like this, what this means is that this was a project in which there was, in year 0, there was a $600 investment. So you see it on a negative side, the red bar over there. And you had a savings of, let's say, slightly over $200 a year. And the constant stream, the positive side over there is the savings. So that's a cash flow diagram. A lot of time people present information in this form. Again, this is the simplest form over there. There could be a lot of variations in there. Another terminology that you will hear a lot in energy accounting and benchmarking and project justification is life cycle analysis. Simply put, life cycle cost analysis or life cycle project analysis will be you take all into account all your initial costs, soft cost and hard cost, whatever your maintenance cost savings or additions going to be, what are your operating costs, what are your energy costs over the years, what is the salvage value of that project that you're doing basically at the end of 10 years, 5 years. So you take all of those things into account when you're doing a life cycle cost analysis. There are softwares available for that, but there are a lot of assumptions over there when doing life cycle cost analysis. That's why it's mostly people use a simple payback, which actually gives you pretty good understanding of where your priority or where your project should be. So the idea over here is just to give you a quick overview of these are different terminologies that are used in there too. So it looks like we have another poll question. How do you track your energy? How do you track your energy? And the options are, we don't track, we have spreadsheets, commercial software, Energy Star Portfolio Manager, or other. All right, so we'll close the polls over here, and the poll results are, how do you track your energy? 5% said none, facility energy not tracked. So 43% said spreadsheet, 33% said commercial software, and Energy Star Portfolio Manager, 5% said Energy Star Portfolio Manager, and 14% said others. So they're using some other ways to do this thing. Interesting, very interesting. So energy accounting software. Energy accounting is an important practice to monitor energy consumption for facilities. Various software tools are available in the market and some are free, and I'll tell you which one is free. You already guessed it, Energy Star Portfolio Manager. However, it has some limitations. It may not do your demand and some of the other functions, but for your EUI, ECI, tracking and benchmarking is a pretty good tool. Today I will just give you a quick overview of what we're going to be covering in tomorrow, but this is something that you may want to consider. You can use spreadsheets. A lot of people do that, and evident from the polls over there, and a lot of people are using commercially available other software to do that. So different ways you can accomplish the goals. Energy accounting system benefits include maintain historical data and set goals, track changes, budget energy cost more accurately, evaluate energy program, and identify and correct anomalies early. So, weather, floor area, operational changes, and so on and so forth. Now, a lot of it depends on how accurately you put this data in there and what kind of functionality do you have in your spreadsheet or in your software. So, a lot of depend on a lot of things. And the most important thing is you want to have this energy accounting software so that you can communicate results. You can tell people where you stand now, where you're going to stand in the future, where have you been in the last, let's say, 2 years or 3 years. So if you're doing regular tracking, you will have answers to all of those questions. The next 2 or 3 slides is very quick general overview of what is going to be covered in slightly more detail tomorrow. What is a portfolio manager? So developed by EPA and DOE as part of Energy Star program. It's an online energy and water tracking tool, and something that as a part of a SECO technical assistance program, we're able to give one-on-one training, and we've done one-on-one training with a number of facilities, and usually in a 2 or 3 hour training sessions, they've been able to utilize this software to the maximum. What is a portfolio manager? So compares to national database of buildings of similar type, climate, usage, and so on and so forth. So So again, important thing is that it does some weather normalization of your data, and it compares you to a national database, not just a local one. It gives you a score from 1 to 100, 100 being the highest, and if you have a score of 75, you may be eligible for Energy Star building label. There are a lot of other criteria that you have to do that, but if you have a score of 75 and Energy Star Portfolio Manager, you can get recognition. And it calculates EUI and ECI for all building types. Certain restrictions apply, and those will be covered over tomorrow at the square footage, minimum size and maximum size, and so on and so forth. But if you want an Energy Star labeling for your certification, then you have to convert a lot of your data. And a lot of these commercial software, by the way, have means where you can upload your data into Energy Star Portfolio Manager to get these ratings also. So something that most of these commercial software has been doing. And also, before I get into that, you can ask your utility data to provide you the data in a certain format, which I think Chris is going to go over with you all tomorrow. And once they do that, you can automatically upload the data into Energy Star Portfolio Manager. So just something I want you all to be aware of. That's something we'll be covering tomorrow in more detail. So typically what you see over there on Energy Star on the main page, on the page Portfolio Manager, is that if you've entered all your data, your current score or dashboard will represent your EUI. Remember, we discussed what is the EUI, whether it's scored or not scored, basically. So you will have that information. Then you enter a lot of your property information on the left side, property details. You have to enter some of this data in there. And then it gives you benchmarks basically for 2015 currents and projections and so on and so forth. So you can export your data into Excel. It also gives you how much emission reductions and so on as calculations for you. So you can set your targets, your goals by doing an Energy Star Portfolio Manager. So a number of other benefits for it. And again, as I mentioned, if you're using commercial software and you're wanting to use do a certification and Energy Star recognition, then a lot of these software has got tools where you can upload your data to Energy Star Portfolio Manager to keep track of it for the scoring and for certification recognition. So I just like to recap what I went over. We went over important EUI and ECI, Energy Use Index, Energy Cost Index. We covered some simple concepts about payback, cumulative payback, and how to forecast your future budgets based on the energy cost index and so on and so forth. One thing I wanted to point out is that the SECO schools and local government program is specifically designed to provide this type of technical assistance. So a lot of time when we are people who have requested it, we're able to enter their baseline utility data into a specific spreadsheet. We also upload it to Energy Star Portfolio Manager, and we train the owner representative in how to use it. And so that's all the things that I went over in this presentation is actually a small but very significant portion of what the SECO schools and local government program is. The other program that SECO has is the Lone Star, which is a funding source basically. You know, if you're looking at funding some of your programs, Lone Star is a very good program to have. And if you go visit SECO's website, there are other programs that you might be having interest in, basically. So just wanted to make sure that everyone is aware of it. And unfortunately or unfortunately, if you want some technical assistance, you have to fill up a simple one-page form and turn it into SECO, and typically within a week or so it will be processed, and a specific request is being addressed, basically. So I hope some of this very fundamental, basic, very fundamental information was useful, and you can use some of this information in your daily use. If you are not already using it, or if you were using it, you may want to share it with other people. So with this, I'm going to be open to if there are any questions that you might have. On the bottom left side is my name and information. On the bottom right side of your screen is primarily this Stephen Ross with the SECO schools and local government program manager. So his information over there. If you have any more questions on some technical assistance or you may need anything like that, you can contact either one of us and we will definitely love to get back to you. All right. Open to questions. Oh, just a very good remark. Not a question, but a remark. Very good stuff. Thank you. Well, I thank you for taking the time and listening to me. I will leave it open for another minute or two to see if there are any other questions. If there are no other questions, we will wrap this thing up. Very important is that we will be distributing this this presentation. You will get a PDF copy, and also I think within a day or two you will also get a video copy of it also, where you can listen to the whole webinar, and all that will be communicated to you. So again, this information is going to be available to you very soon. The PDF should be going out probably tomorrow, along with the actual webinar that you could share with other people, basically. So if there are no questions, I think we are at the end of our time frame, right? Yeah. Okay, so I am going to close the session, and again, thank you very much for taking the time and attending this, and we look forward to seeing you guys tomorrow. Bye.